Hey guys, Mr. Burns here with your video for lesson 3.7, compound probability. So just a little forewarning, this video might be a little long, and I totally understand that. Probability is a hard concept in mathematics to kind of learn about and study and really wrap your head around. It's kind of a hard concept. I've used the analogy of video games before and probability. And if you've ever played a game of some sort, you know you're dealing with probability. But it is a hard concept to master, and especially to get introduced to, and sometimes to teach. I was not a master at probability, but here I am. So I'm going to read through this with you guys. As far as Easter eggs go, there might be a little Easter egg, a little hidden egg, somewhere in the video. I might take a brain break and give you guys something fun to do while you guys are going through this video. So make sure you pay attention, make sure you're listening, because it is worth points. All right, here we go at the top. Again, just reading through this, and then we'll definitely dive into it when we get into the tiered part of the worksheet. So here we go. A single event like rolling a number cube and landing on 1, or flipping a coin and landing on heads is considered a simple event. Everything in the unit up to this point has been examples of simple events. A compound event consists of 2 or more simple events kind of lumped together. 3 ways that you can determine the number of possible outcomes when looking at compound events is to use a tree diagram, a list, or a table. So in example number 1 here, it says you are packing for a trip. You decide to take 4 shirts and 3 shorts. How many possible combinations of 1 shirt and 1 pair of shorts are there? So 3 different ways, like it says, you can do this is with a tree diagram, which is illustrated here, because it looks like a tree. And what you do is you take the number of shirts, okay, and you combine it with the number of shorts. So there's different combinations, right? Same thing with a list. You can make yourself a list, short with shirts on the left and shorts on the right. And then make yourself a table, okay, like what might be called a rectangular array of possibilities, okay? So those are 3 different ways that you can set this up, and I'll use a variety of ways in the tiered worksheet. Okay, so in this case, there are 12 different possible outfits. So a compound probability, so I'm reading at the bottom there, a compound probability is the probability of 2 or more events occurring. Sometimes the events are independent events, which means one does not affect the other. Rolling a number cube and tossing a coin are independent events. Sometimes the events are dependent events, which means one event depends on the other event. So choosing 1 card from a deck of cards, keeping it, and then choosing a second card is an example of a dependent event, because you're keeping 1 card, that's 1 card in your hand, and then you're choosing another, okay, that's 2 cards in your hand out of a deck of, let's say, 52. So it's a dependent event because you're lessening the amount of chances possibly. All right, so it says by keeping the first card, you have changed the possible cards to choose from the second time. Okay, so next page. So in this one, it says to find a compound probability, make a list, tree diagram, or table to count the number of possible outcomes and then count the number of favorable outcomes. Now up here, you've got this ratio, okay, when you're talking about compound probability. So in that case, it says possible events, so the probability of events is equal to the number of favorable events divided by the number of possible outcomes. Okay, so favorable is in the numerator and possible is in the denominator. Use a tree diagram, use a list, tree diagram, or chart to find the number of favorable outcomes and the total number of possible outcomes. So in example number 2, it talks about Cindy. Okay, it has 3 letter tiles. It spells out the word cap. We're not going to go too far into this example because there's a problem in the 3.7T worksheet that talks about this. But what you want to look at, okay, is how it's set up. So if you guys get lost, okay, go back to the videos, okay, and look how these problems are set up. So again, if you look down here where it says find the probability on the very bottom, so the number of favorable outcomes is in the top, okay, and the number of possible outcomes is in the bottom. So this is favorable, okay, this is possible. So the notation puberty, the notation for compound probability is similar to the notation for simple events. As seen in example 2, the probability of getting C, then A, then P is written probability of C, then A, then P. The order in which the events should occur is specified by the order they are listed in parentheses. So there's a method to the baldness. You gotta pay attention. Okay, I'm gonna go on to the next page. So in this part of the video, there's 2 more examples, example 3 and 4. So the first one is talking about LaShawn, Kay, and the Spinner, and the second one is about a candy bar company. But what I want you to pay attention to is this right here, Kay, the simulation. So simulations can give a good estimate for a probability when it is difficult to determine. A simulation is an experiment you can use as a So a simulation is an experiment you use to model a situation. Think science class. When you guys are in science class, you run experiments, right? It's a simulation. It just happens to be that experiments are run in science class. Simulations can be run in mathematics class. Same thing, different context. You can use coins, number cubes, random number generations, or other objects to simulate events. The more trials you simulate, the better your estimate for probability. Okay, next part of the video. Okay, so in this part of the video, we're getting into the worksheet here. So I'm going to expand the video the screen just a little bit so you guys can see what I write, and hopefully it makes more sense to you. So anyways, let's take a look at number 1. Number 1 says LeBron James. LeBron tosses a coin and chooses a card from a deck that has the numbers 1 through 4. Answer the question below to organize the possible outcomes for tossing a coin and choosing a card from the deck that has the numbers 1 through 4. So in this case, they're going to sit there and they're going to use a tree diagram, okay, to tell you, show you what the possible outcomes are. So for part A says, complete the tree diagram to show the possible outcomes. So when you flip a coin, in this case, they're saying heads. And then what are your possible outcomes for the card deck? So you got 1, 2, 3, and 4. What's the other side of the coin? Why, that's the tail, of course. So tail. And what are your possible outcomes when you're choosing the numbered card? Well, 1, 2, 3, and 4. Now, the one thing you want to pay attention to, and this is me being OCD, yeah, that was a rhyme and it ain't no crime, is this right here, the order of the numbers. So the numbers are going in order, 1, 2, 3, 4. It's really important that when you're running a simulation in compound probability, that you stay organized. Same thing here when I flip tails, my numbers were numbered 1, 2, 3, and 4. So again, it's really important that you stay as organized as you possibly can, guys. I promise you. Trust me. So part B says, complete the list, okay, to show the possible outcomes. So another way you can do this is to write a list. So heads 1. So what's the other possibility? Heads 2. And I'm going to go across. Heads, what's my another possibility? Heads 3. And the other one, heads 4. Where the first letter, heads, H, stands for heads. That's the one side of the coin. And then 1, 2, 3, 4, that's my cards. Now I'm going to take care of the tails. So tails 1, what's another possibility? Well, tails 2, then tails 3, and then tails 4. All right, that's a list. And then the last one, so B is the list and C is the table. So on the table, so going across the top there, you got 1, 2, 3, and 4. And then they're going up and down that column, you got heads and tails. So one possibility is H1, okay, heads 1. Going across, then I've got heads 2, heads 3, heads 4. The other possibility for the tails, so what are my tails? I got tails 1, tails 2, tails 3, and tails 4. All right, so then it says, count all the possible outcomes from the tree diagram, okay, list and table. How many possible outcomes are there for tossing a coin and choosing a deck of cards, and choosing a card from a deck that has the numbers 1 through 4. So here we go. So here's one possibility, right? Let's take a look at the list. So this is 1, 2, 3, 4, 5, 6, 7. There are 8 possibilities. Okay? So hopefully that's helpful and hopefully that makes sense. If it doesn't, come and ask me. Don't be afraid to ask me. We're definitely going to go over lesson 3.7p. Okay, we're going to go over a few of those as a class. There's 9 of them. We're going to go over a few of those, but don't let that stop you from doing the assignment. Try it on your own. Okay, try it on your own, and let's bring your interest to class. Okay, let's take a look at number 2. Okay, on number 2 and 3, the instructions are: use a tree diagram, list, or table to find the number of possible outcomes for each situation. So number 2, you said pick a card, okay, 1 or 2, okay, and toss a coin. So heads, tails. So in this case, I'm going to sit there and make a table, right? So what are my possible outcomes? So my first possible outcome, let me clean this up a little bit. So one possible outcome is heads 1 or heads 2. The other possible outcome is tails 1 or tails 2. And what I do is I count how many possible outcomes there are on the inside of the table. In this case, there's 1, 2, 3, and 4. So there's 4 possible outcomes. All right, there we go. Let's take a look at number 3. Okay, so on number 3, it says choose one type of gum, berry, mint, or bubble, and choose one type of drink, water, milk, or juice. Sounds like a tasty combination. So what I'm going to do in this case is I'm going to make myself a list. So what I'd like to start off with is berry, mint, or bubble. So for the berry gum, what are my possibilities when it comes to drinks? Well, there's water, there's milk, and there's juice. If I choose mint, okay, what are my possibilities there? There's water, milk, and juice. Okay. And then when it comes to bubble gum, so bubble gum, when it comes to the drinks, there's water, milk, or juice. So how many total possible outcomes are there? Well, count out the number of combinations, like bubble water, bubble mint, bubble juice. Okay, that's 3. For the next column, there's mint water, mint milk, and mint juice. So there's 3 possible outcomes there. And then last but definitely not least, there's bubble. You can have your bubble gum with your water, your milk, or your juice, which is 3. So it's 3 plus 3 plus 3. It's 9. So there's 9 possible outcomes for number 3. All right, next page. All right. Here we are, number 4. So on number 4, we've got Kesha has 4 letter cards that spell out math, M-A-T-H. Kesha picks 4 cards, one at a time without replacing them. Answer the questions below to find the probability. Kesha picks the 4 cards in the correct order to spell M-A-T-H, which is math. A, it says use a tree diagram, table, or list or table to find the number of possible outcomes. Order Kesha's orders. Kesha could pick the cards. So B says count the total number of outcomes. How many are there? C, count the number of outcomes that spell math, M-A-T-H, in that order. How many are there? D, find the probability. Kesha chooses the cards in order M-A-T-H, okay, over the total number of possible outcomes. So here's what we're going to do in this one. In this situation, what I'm going to do is I'm going to make myself a list, I believe is what they call it. So here we go. So my list. So M, I'm going to start off with the letter M first. And this is going to take some room. Okay, so what are my possible outcomes here? So M. So I could go M, A, T, H. And then what I'm going to do, like I say, I like to stay pretty organized. So I'm going to say, what are my other letter combinations? So M-A, H-T. What's my other letter combination? M, T, HA, then M, T, AH. My last letter combination, or my next letter combination, could be M, H, AT, and I'm going to try and shrink this down so I can put my last combination. Give me just a second. And my last letter combination is M, H, T, A. Now let's take the next letter in the sequence, A. Okay, here are my combinations for A. Watch what I do. A, T, H, M. So I'm reshuffling the cards, guys. Pay attention. So A, T. What am I going to switch? Well, you got it. M, H. Next, A. What's the next letter in the sequence? That's H. M-A. I'm sorry. So it's going to be A, H, M, T. And then I'm going to go A-H, T-M. Okay, let's see here. Then I'm going to go A, M, T-H. Then A, M, H, T. All right, you guys with me so far? I told you this is going to take a while. Okay, next letter combination. So in the letter, so I've got taken care of my M, I've taken care of my H, or my A, now I'm going to take care of the T. So all of the letter combinations I can make with the T. So T, H, M, A, T, H, A, M. Then I'm going to go T, M, A, H, then T, M, H, A. What letter do you think is going to come next? You guys are catching on, aren't you? Well, you got it. So T, A, H, M, and then T, A, M, H. Okay, we only have one letter left, and that is the letter, oops, not the letter oops, but the letter H. So here we go. So H. So we got H. What the world? H. M. A. T. Then H. M. T. A. Then H. A. T. M. Then H. A. M. T. Finally, we've got H. T. M. A. Then H. T. A. M. Now, that is a boatload of writing, but there you go. That's your list, right? List of combinations. Now, let's find out how many combinations there are on each list. Well, if you count down, so you got 1, 2, 3, 4, 5, 6, there's 6 combinations there. 1, 2, 3, 4, 5, 6, there's 6 combinations. The next, okay, the next list, there's 6, and the next list, there's 6. So there's 6 combinations in each column, right? So count the total number of outcomes. How many total outcomes are there? There are a grand total of 24 outcomes. Because 6 plus 6 plus 6 plus 6 is 24. It says count the number of outcomes that spell math. So out of all of that, how many are there? There's only one. All that work for one outcome, but there you got it. So then it says the number of outcomes that spell math, there's one out of how many total? That's 24. Okay, here's your Easter egg. Pay attention. Go to the back of your page. Okay, go to the back of your packet. What I want you to do right now is I want you to write down, okay, 5 things that you love about your parents. Okay, so on the back of your page, okay, on the back of your worksheet packet, I want you to write down 5 things that you love about your parents. Okay, after you're done doing that, let's jump to number 5. On to number 5. And 6, it says find each probability. Use a list tree diagram, or table to identify the favorable outcomes and the total number of possible outcomes. So here we go. Number 5 says you roll a number cube, okay, 1 through 6, and toss a coin, heads and tails. Okay, what is the probability of rolling a 5, okay, and tossing a tail? So what I'm going to do is I'm going to make me a list. I'm going to choose the number of, number cubes, to start my list off. So I got 1, 2, 3, 4, 5, and 6. So for the number 1, what's the possibility? And actually, I'm going to do this. Sorry, guys. So if I roll the number 1, what are my possibilities for for the coin toss? Well, I got 2 possibilities. I've got heads or I've got tails. For number 2, say I roll a 2. What are my possibilities for the coin cost? Well, heads, tails. Sorry, I changed my explanation a little bit. Same thing. Let's say I roll a 3. What are my possibilities for the coin cost? Toss, heads, or tails. For the 4, let's say I roll a 4. What's my possibility for the coin toss? Coin toss. It's heads or tails. 6, roll a 5, not a 6, not yet. So roll a 5. Coin toss, heads, tails. And for the 6, what do I got? I got heads and I got tails. So what's the possibility of rolling a 5? Okay, and flipping tails, that's 1. Out of how many total? Let me choose a different color here and I'll show you. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 possibilities. So that is my denominator. So again, the numerator is your number of favorable outcomes and your denominator is the total number of possible outcomes. Okay, let's talk about number 6 and Tyrone. Tyrone has a deck of cards numbered 1 through 5. He chooses 1 card, replaces it back in the deck, and then chooses another card. Find the probability that he draws a 2 first, then chooses a card less than 4. Okay, so in number 6, I'm going to do this a little bit differently, mainly because it's easier for me to explain and it's easier for me as a teacher to wrap my head around. So what are the possible cards? I've got 1, 2, 3, 4, and 5. So if I'm using my ratio, how many possible outcomes are there? There are 5 possible outcomes, so that's my denominator, right? So what's the probability, okay, that he draws a 2? Well, that's the number of favorable outcomes, right? Well, there's only 1 card that is numbered 2. You guys with me so far? So there's a 1 in 5 chance that he's going to choose the 2. Now, from what I understand, he chooses that card and then he replaces it back in the deck. So again, on the second draw, you're going to have 5 cards in the deck. So let me do this real quick. So there's a 1 in 5 chance that he will choose a 2. Now, this is the first draw. Now on the second draw, it says find the probability that he draws a 2, okay, and then chooses a card less than 4. So if he takes the 2, that's his first draw. There's a 1 in 5 chance. Okay, and then what's the probability that he chooses a card that's less than 4? Well, how many cards are less than 4? 3, right? So there's a 3 out of 5 chance, okay, that he chooses a card that's less than 4. So what's the total probability? So to find the probability that he chooses a card that is less than 4, you take the probability that he chose chose the 2, which is 1 out of 5, and you multiply that, okay, to the possibility that the probability that he chooses a card that's less than 4, which is 3 out of 5. And then when you multiply fractions like this, you should multiply straight across, numerator times numerator, so 1 times 3, that's 3. And then denominator times denominator, which is 5 times 5, and that's 25. Not 35, Mr. Burns, 25. Okay, so there's a 3 out of 25 chance that when he draws a 2 first and then chooses a card that is less than 4. hopefully that makes a little bit of sense to you. If you guys have any questions, guys, you've got 9 problems on the next page on the practice worksheet. So if you have any questions, make sure you come and ask me. I'll be more than happy to help you out. That's all I got. Mr. Burns, out.